Hello and welcome back. In this video, we're going to talk about how you can convert whole numbers into fractions. So the first number we're going to look at is, let's say, the number 2. So I already explained from before that you can represent whole numbers, or for example, you can represent the number 1 by the division problem 5 divided by 5, for example, and this will also look like the fraction 5 over 5. But the thing is, you'd get the same answer if you did a fraction like 6 over 6, or 7 over 7, or 8 over 8, because the fact is that all of these fractions are this division problem 6 divided by 6, 7 divided by 7, 8 divided by 8, and they all have the answer of 1. You can do this with every other integer number, and an integer is just like a whole number like 1 or 2 or 3. And so what if we try to represent 2 the same way that we just did it with 1 and these fractions? So if we try to do it with 2, what kind of a division problem would give us an answer of 2? Well, 2 divided by 1, or we could say 4 divided by 2, or 6 divided by 3. All of these would give us the answer of 2. And so we can also rewrite these to be 2 over 1, 4 over 2, 6 over 3, and etc. You can do this on and on and on and on. There's an infinite number of ways you can represent this number. So let's say we're still trying to represent 2. How would we represent 2? So let's say we want the denominators to be 2, 3, 4, 5, or actually 2, 3, 4, 5, 7, and 8. What's the numerator that we would have in all of these examples so that they would all equal 2? They would all be fractions that equal 2 if you did the division problem. So how this works is that you want the numerator to be double the denominator, so that when you divide it out, like in this example, when you divide it out, it equals 2. So here would be 4. We did this here. So here would be 6. So if you notice the pattern, this is always double this. This is always double this. So in this case, this would be 8. This would be 10. This would be 14. And this would be 16. What if we tried that, the same thing, but for the number 3? What if we wanted the same denominator, so 2, 3, 4, 5, 7, and 8, but this time we wanted the ratio between the numerator and the denominator, you want the fraction to equal 3. Well, you just have to make sure that the division problem that you can set up equals 3 in the end. So what number divided by 2 equals 3? 6. 6 divided by 2 equals 3. And when you simplify this, you can simplify this into 3. What if our denominator was 3? Well, if you notice the pattern, the way you do it is you multiply this number by the denominator. So here would be 9. And here would be 12. Here would be 15. Here would be 21. And 8 would be 24. We're using our knowledge of the multiplication table to help us fill these values out. Now let's try it again for the number 5. How would we fill these numerators out? if we wanted to have equivalent fractions, equivalent improper fractions with these denominators. For the denominator of 2, the way we would do it is multiply 2 by 5 to find the numerator. So that's 10. Here, 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is 25. 7 times 5 is 35. 8 times 5 is 40. And these fractions are all equal to each other. They just have different ratios. But once you divide it out by translating into a division problem, it looks like the same thing. So this is how to write equivalent fractions that represent integers, and we did it for the examples 2, 3, and 5. You can continue to do this for any integer. You just either have to know their multiplication table, or you calculate out on the spot what the fraction would look like. And that is how to convert integers into improper fractions. Thanks for listening, and see you next time.